Hi, my name's Gary, and this is my first podcast. And I'm here today with somebody who graduated from Boston University, has a lot of experience in engineering, and works on space projects. So,
And
I,
sometimes subs.
yep, sometimes subs. Um, I, jeez,
It's tough thinking on the spot.
yeah. So I was an aircraft mechanic for over a decade, and so I have a lot of experience when it comes to pressurization. And I also have a bunch of friends who went on to work on submarines. So like I kind of have a pretty decent idea of some of the characteristics around the situation of the Titan submarine. And I'm sure that there are a bunch of people who are going to beat this topic to death, so I probably won't release this right away. But we're here to talk about not necessarily to bash the company Ocean Gate, but to just talk about what they did right, what they did wrong, and kind of like overall our take on the situation that happened. So to start off, I want to talk about the submarine and how it had over 50 test dives. So like apparently like they did a bunch of dives with the submarine off the coast of the Bahamas, and so they were diving to the depths of 12,500 feet, and they did it multiple times, um, like in different facilities. Like they wanted to be absolutely sure that this thing wasn't going to like kill them as soon as they used it. But I guess like a lot of people warned the CEO that the materials that he was using were unsafe, and I guess even people who worked for him told him that the materials were unsafe. And one guy, his name was, let's see here, because where I wrote it down, David Lockridge. I guess there was a guy named David Lockridge, and he had voiced his concerns, and I guess no one was really listening to them. And but he went into great detail of what he thought was wrong, and so I guess he ended up like saying that hey, other submarines that they get certified by an independent company, and like there's standardization around submarines, and the CEO disagreed because he believed that there was room for innovation and that people weren't exploring the possibilities. And I guess like one of the overall characteristics that he was looking at was that he wanted to make a submarine that was lightweight in comparison to other submarines that are made of titanium with this foam. It's called syntactic foam,
Hmm.
and I guess that's like the industry standard for most submarines. So I guess another thing that was said was that the CEO bragged about how he got a discount on the carbon fiber from Boeing.
Yeah, carbon fiber is already a huge red flag for me out the gate. I mean, I didn't know that that there was any carbon fiber involved until like even a couple of days ago because I started hearing about it, but I was just like, but where? And then I hear the cylinder, the center section, it's carbon fiber. I'm just like, what are you thinking? Like, carbon fiber is like wood, it's fiber. So it splinters like wood. It wants to come apart. It's wild.
So he said he got a discount on the carbon fiber because I guess it was reaching the end of its shelf life. So Boeing wasn't gonna like try to use it to make airplanes, which I find is extremely interesting. And I did a little bit of research, like trying to look into like what actually is the shelf life of carbon fiber, because I've had like mixed messages about that. And I know like there's a lot of things that can affect carbon fibers, like UV light, like and mostly like the breakdown of the epoxy resin that's used in the construction. I just wanted to know what your take on that was.
Well, so for what I do for work, I can't say too much, but a lot of things have shelf life, a lot of chemicals, a lot of materials we work with. But I feel like from what I know, a lot of that is we have a period of time called a shelf life, at the end of that shelf life, we want to check on it and make sure it's good to use moving forward, because eventually the material does break down. These materials do, these really special materials do have a half life. They have a point where they're not going to work anymore. So we kind of check on them and check on them. And I don't think Boeing would sell something that they know wouldn't work anymore unless they're going to completely say, this thing, the shelf life is useless on this, so use at risk or something of that nature. Or unless they scrapped it and somebody else decided to sell it afterwards. So it's a very strange situation to me to have a carbon fiber that Boeing or any company, any engineering company isn't willing to use, and to use that at the great depths of the ocean.
So it's interesting that you said that like Boeing wouldn't even sell it because they wouldn't want to take any like perceived liability for what the intended use would be for that material. And I think that's interesting because I guess at one point they had said that they were working in conjunction with a bunch of different people. They said that they were working with a college. I want to say the some college in Washington,
I heard about that. Yep.
and then they said that they were working with Boeing Engineering, and I think they said even that they had like consultation from some other area of engineers. But like all these people that were mentioned all kind of like gave their input and said, no, we didn't have that much input in the project as it's making it sound. And like Boeing said that they didn't do it because like I think as a big company with like a lot of stakeholders that you would definitely want to state that because like when an incident like this happens that like lawsuits are going to come in and you want to just make sure that you're covered and being like, no, I wasn't really a part of this project.
Right, and I know, like, what I remember from Boeing's perspective is they said they have no purchase order from saying they sold that carbon fiber to Ocean Gate or anybody else, and they said they had no engineering involvement, which may or may not be true. It's hard to tell. And then I don't remember the name of the college. I really wish I did, but they mentioned that they did do a $2 million contract for their pressure chambers because I guess they had like a water pressure chamber, and they mentioned that they barely got halfway through the contract, but not even to the $1 million point, and they had to stop or cancel it. I don't know exactly what happened,
Yeah,
but
they only made it to $650,000 of that obligation.
Mhm.
So I don't know what happened there either.
Well, I heard, and just speculating, I'm not fully sure, but I heard that during their testing, they damaged the chambers due to implosion from that carbon fiber material.
Really?
And so the college had to go and do repairs, so they couldn't continue working there. And then I don't know what happened after that. So they were using those chambers and not having success there. So I don't know why they continued forward.
So okay, so now that I'm going kind of out of order of what I wrote, but this will go together with what we're talking about.
Mm-hmm.
So that the guy David Lockridge, he had said that one of his concerns was that they constructed the hull to 5 inches thick, and I guess they originally had intended for the hull to be 7 inches thick. And so he had mentioned that that was one of his gripes. And so I kind of wanted to talk about carbon fiber tension versus compression. And what I read about carbon fiber is that its main strength is tension and not compression, and that compression strength on carbon fiber is only 30 to 50% of its tension strength.
Well, to me, I don't think that's your main issue you want to be concerned with when you're using like any type of fiber, like a carbon fiber or fiberglass. To me, what you want to worry about is over time, that stuff splinter. It acts like wood. It starts to swell, it starts to splinter, it starts to peel off. So that strength that you had at the beginning, just a few short years down the road, maybe not even, depending on how much stress you're putting on it, it doesn't have that strength anymore. Like it'll have a core strength for a good period of time, but unless you have over designed it to the point where your safety factor or like the amount of stress that carbon fiber can handle is way more than you're putting on it, like you might make like a carbon fiber frame for a bike, which I don't know exact numbers, but it's gonna hold a couple times what a human being weighs, right, to undergo the forces of being a bike. Unless you're in that realm, then it's gonna not work for a long period of time.
So you're saying that because of the fatigue value, that it's going to uh, decrease in strength a lot quicker because of the extreme conditions it was put in.
Yes, so fatigue stress is something you've got to worry about because you may use something once and it'll work just fine, right? So you might be able to go down to really deep depths, or you might be able to use something over and over again, but eventually over time, if you keep doing that, it's going to fail. It's kind of like why we check on bridges and highways, because when we build them, they handle the weight and stress and pressure just fine. But it's not like weathering over time that, rust is a little bit of a factor, but it's really the stress of constant use that comes into play. That's the reason why we've got to replace highways, repave roads, redo tunnels and stuff like that. Same factor here, but even at a lesser scale, because carbon fiber is really, it I don't know what the best way to describe it. It delaminates, it peels, it kind of splinters off like fiberglass or wood would.
So, with that being said, when we were talking about inspections, and so when I worked on aircrafts, the aircrafts that we were running were actually running 4 times their expected life expectancy. And the way that they decided that they were going to deal with it was that they were going to do what's called an MDI inspection. And so they would do like an x ray of the plane and they would look for cracks in the ribs of the structure of the plane to see if the plane was losing its structural integrity. And so I guess with like a lot of submarines, they do a very similar process. And most submarines have, like a titanium or, metal structure that they can do that with, but they can't do that with a carbon fiber. And so what they did was they said they had like some acoustic um, sensor system that would detect the whole, starting to break. But from what I'm hearing, like based off of the nature of the situation they're in, it's not at the point that you start to hear that there's a problem. It's already kind of too late.
Yeah, have you ever seen that Mythbusters episode where they sent like a diving man suit 300 feet down and they kind of filled it? I forget what they filled it with. They filled it with like just various meats, and then they kept it pressurized 300 feet underwater, just 300 feet, and then they took off the pressure, right? So now they no longer have the pressure of keeping that suit fully pressurized at 300 feet so that there's equal pressure inside and out. And it's just the pressure of the ocean versus that body of meat. Did you hear about that or know what happened there?
So my wife told me about it. I did not see it, and I actually only heard about it today.
So it was like those old, like, you've probably seen some old cartoons where they'll have like the out leather suit or whatever, and then the helmet of the underwater suit's like made of metal, and it's
Yeah.
got the glass covers on the front and the sides and whatnot. Basically, what ended up happening when Mythbusters did this experiment and they took out the pressure from the suit, so it was just the pressure of the meat inside the suit versus the water, the entire body shoved into that metal head, which was already being crushed by the water at 300 feet.
Wow.
So the moment that the pressure from the outside can get inside, it's just game over. Like, there's no bodies to go get at this point. There's nothing to retrieve because of the amount of pressure involved.
Okay. All right. So, let's see here. So another thing about I want to talk about Dave Lockridge's concerns.
Sure.
So on top of that whole thickness, they had like the one window, and the window is actually part of the naming of the submarine's first name. So they were making submarines, and their first one was called Cyclops One, and so they made this submarine, and its code name was Cyclops Two before they called it Titan. And so the window that they used was rated to 1,300 meters,
Mm-hmm.
but they were diving to a depth of 4,000 meters, and so I guess I would like to know what your take on that is.
So it's funny you say that because before I'd known about the carbon fiber hull, the first thing I was thinking is if anything were to fail, it was going to be that window because I had heard about that the window is only rated to 1,300 meters, which keeping in mind that that rating means like it could handle a lot more than 1,300 meters, but like I was saying with fatigue stress, for how long and to what extent. There's, for OSHA certification and ASME ratings and stuff like that. Usually, like whatever your load rating is, the bare minimum point that object can actually lift or handle force wise is 120% of whatever the rating is. Um, and then after that, who knows? Like there could be more, but that's just the minimum to meet that rating. I don't know what the rating's based off of, but I can tell you if it says 1,300 meters, it can handle more. How much more? You don't want to play that game and find out. And for how long, too, because at 1,300 meters, there's probably a period of time where that's rated for. And then after that, you're going to have to check. Um, and then once I found out about the carbon fiber hull, I was just like, well, that makes sense. That's not a good move.
So going back to the carbon fiber hull, because that seems to be coming back a lot, and we keep talking about that because that's like a very big um, focus area. So I was looking into the construction of this submarine, and I actually found a video showing them actually mating the titanium surface to the carbon fiber hull, and I watched them paint like use a paintbrush to put epoxy on the inside of the titanium and on the carbon fiber side, and basically like they came down with like a crane and they like dropped the titanium part on top of the hull, and I thought that was really interesting. Like that was the way they decided to go about it. And so I guess going back to David Lockridge, one of his concerns was what was going to happen with that epoxy over time.
I mean, I could see that being an issue. I don't know if that would be the main factor at play. I feel like I'd be more concerned with, like I was saying, with the carbon fibers that it's structured in forms and layers, and something for example, in the industries I work in, like you're concerned with material certification, what metals are involved, so that you make sure there's a uniform structure of the material and it can handle stresses. Like sometimes we X-ray stuff as well, and we don't do a lot with welding because welds don't work well in the environments that I work in, particularly. Not the case for everything, but usually when pressure is not involved and there's a lot of vibration, welds don't handle well. So that's kind of stuff I worry about in my industries. So when you're factoring in, going into depths and whatnot, I don't know what they did with this carbon fiber to check to make sure that it was structurally sound. Could probably do acoustic tests or something, but I feel like they didn't do their due diligence there. I see they were smart with the caps on the end because the ends were titanium. And if you're making kind of like a propane tank like structure, the ends are where your weak points are actually going to be because that cylinder structure is a very strong shape to have where you're going to have uniform pressure on all points in all directions. Whereas the end caps, you're not because it's spherical, but just at the ends.
So I was going to bring that up. So most deep sea vessels, I guess, are like very much a sphere construction,
Mm-hmm.
and they're all metal.
Mm-hmm.
And this one, people were saying that the way this would displace energy, that there might not be like a proper transfer of energy from the carbon fiber to the titanium section,
Mm-hmm.
and also because they were flush mated with the epoxy, that would also figure into that as well.
Yeah, that's what I'm thinking is just the stress in that horizontal direction, going from titanium to carbon fiber and so on. Um, there's that stress in that direction as well because it's not just around the cylinder; it's pushing out at the ends too. So that could be a huge factor in that. And I don't know how, I understand that about that epoxy, but I don't know how strong that epoxy is. And I wouldn't want to trust that. I would want a uniform material so that I don't have to worry about two different materials debonding at some point in time.
Right. And that's why the whole thing about how there was no independent inspections from like a third party. And I wasn't sure because they said the CEO of the company was a very smart guy and he had an engineering background. But they were saying if I had to guess and if I was in that guy's shoes and I was trying to make something that was revolutionary, I guess my concern would have been that I wouldn't trust the independent body because you weren't sure who was going to try to steal trade secrets of yours. But in the same breath, I think having like a governing body that can tell you what's right or wrong with your vessel is because it needs to happen, especially for the safety of civilians who are basically entrusting their lives to you. When you're going to go do something as extreme as this.
Hmm. I mean, you can be the smartest guy in the world, but if you had bad habits or if there's just bad processes in place for handling a situation, it's game over. I mean, look at the Titanic itself. That's how it happened. It was a very smart design that was supposed to be able to handle anything, but because people got so confident about it, and because, well, there's so many factors involved with that, but because of the perception and the intelligence and the engineering and the thought that went into it, people thought it was just going to be fine no matter what happened at sea. And I feel like that may have been a factor in just like the lackadaisical processes they had on the boat, and that ended up being making it be at the bottom of the ocean and be a wreck for them to go look at in the first place. So stuff like that, where yeah, I'm sure these guys are super smart and they've been doing this stuff for years, but that could be a factor where they've done this stuff so long that they're just like, this will be fine. Same thing happens in our industries too, where you've got this really high tech stuff. You do one small thing wrong, and people's lives are at stake. And over time, if you've been doing it for years and years, you can be like, you can probably get away with this, because you've done the same thing over and over again. But then, once you get a little bit lazy, or you're just thinking, oh, it'll be fine, I've done it a million times, that's when something goes wrong. That's when someone gets hurt, and that's when lives are at stake.
So another couple key things I want to talk about is like they were showing the picture of the inside of the hull, and they were talking about how um, they believe that they screwed directly into the carbon fiber hull for like the mounts for the monitors and all this other stuff. Like a couple things that I want to mention are there is a metal layer between the carbon fiber hull and the people inside, and that's what the monitors are bolted to. And also that those whole it's a I think it's a perforated surface that was actually heated because when you get down to the depths that they were at, it's like 32 degrees to 36 degrees. And so like they want to keep people warm inside of there. Um, I think they could have done a better job of having a way where whoever was piloting the submarine could have been strapped down in like a seat and so that there was no obstructions to them while they were trying to navigate the submarine. And also I want to say like everyone brings up the controller, and one thing I can say about video game controllers is that like the D sticks have drift. That's a problem. And another problem is I would want to have a controller that was positively connected to whatever source I'm steering. Like when you're talking about like the stakes being that high, I probably would want like the interfaces to not have any way of being interfered with. And so his way of dealing with that was he had multiple controllers on hand. So if like one controller went
Oh, I
bad,
didn't know that.
but one thing I've noticed about wireless controllers is that sometimes when they disconnect, whatever system they were connected to will just remain stuck on uh, the last known input. So like if that's the case, that could make your submarine like spin around in a circle until you can get another controller connected. So there's that. Another thing I found out was that submarine one time they went down to the bottom, like by the Titanic, and it wasn't until they got to the bottom that they found out that one of the thrusters was actually installed backwards.
Jesus.
And so the way they dealt with it was they actually had to map the controller inverse of what it was, and that was their way of fixing as their fix.
Imagine if someone was just, they're trying to get to the bathroom and they walk over and they just accidentally like step on a controller and it just happens to like turn on and take over control from the other controller that the pilot's using of the submarine. That would,
And yeah, and so not a lot of people know this, but I think it was definitely spread around. I guess there was like multiple times that things have happened while navigating with that thing down at that depth. Like I guess one time a current took that submarine and lodged it in between the propeller of the Titanic. And
oh,
then also, there was a time where someone had like a TikTok video and they showed like people on this thing,
mhm.
and I guess they like ran it into a rock because it has like so many blind spots.
Jesus Christ.
So yeah, like imagine running into a rock and you're like 4,000 meters,
well,
down.
well, normally, like if a submarine bumps into something like that, you're taking it out of service for years. So I wonder what their protocol was for that.
I'm surprised that they didn't have like their own shelf life for this thing where like they had other ones ready to go and that they didn't have like okay, well, we can use this periodically, or we can use this like this amount of times and then we're going to, retire this one and then move on to a new one. And I'm sure that's not like very cost effective, but given that you were saying everything that you said about the fatigue of carbon fiber, you think that would have been
Yeah.
taken into
Well, just
consideration.
like I imagine, like if you're gonna try to use carbon fiber, I don't. And again, I don't know if it's been done or who does what, but I would at least try to make like a remote vessel first and play with it, kind of like what NASA does, where when we test the rockets, the SLS, we sent it up, nobody on it, right, and we're just controlling it from Earth. So we're doing that a couple of times, make sure we won't kill anyone, and then we put people on it when we're sure we're not going to kill anyone.
Like you put like a bunch of canaries in a cage, kind of like
No, no, we
like the
don't.
miners would do like back in the day. That's what they used to do. They used to take a bunch of canaries and drop them down
Yeah,
and
well, yeah.
see if they die on their way down and bring them back up. That's what they did. I mean,
Yeah, it's true. We're much more civil these days. So these days, you could just have sensors in there, make sure your oxygen levels are staying up. You can check your pressure level in there without having anyone in it, and have a way of steering it from the surface at least to a certain depth. So if something goes wrong, someone can take over for you. Um, but I don't know if any of that happened, but I don't feel like it did. Otherwise, this probably would have been handled much better.
yeah. And so with that being said about the oxygen, I heard multiple times that they were saying, oh, that they if they were down there, that they would have had 96 hours of oxygen. And a common thing that people are saying is like, with how many people on board?
Yeah.
Like how much oxygen does that account for 5 people's worth for 96
Well,
hours?
also,
Or
it's kind of just like with the spacesuit. It depends because different people have different metabolic rates, and that varies. How much oxygen they need,
right,
how quickly, and then on top of that, when if you're in a situation of like when you're in a state of panic, all of a sudden, you're all of that's going to go out the window
you're gonna
too,
take in more
right?
oxygen.
Because if you can't keep yourself calm, your body's going to want to spend more resources to
Mm,
try to get out of its situation. So I can, like, I don't know what that 96 hours is based off of, but it's probably not like,
nearly what?
well, it's not something you can use as an accurate number to just be like, yeah, it would have been exactly 96 hours.
Okay. So the last thing I wanted to talk about this because we pretty much covered almost everything I could possibly think of about it. So I found it very interesting that the U.S. Navy has this system called the drape system that they use.
Uh
Yeah. So they can basically it's used. It's it's a remote system that tries to detect submarines of adversaries,
oh.
and so they detected the moment that submarine imploded. They heard it,
Yeah.
and it was sent.
Oh yeah.
It was sent to them. So it wouldn't just be the audio from it; it would also be the location of it, and so they would be able to know where it happened. So they would have been able to deduce all this, and I guess this information was given to like the proper important people.
Hmm.
And so I thought it was really interesting that they knew when it happened, how it happened. They knew, they assumed it was an implosion, and yet the news kept people in a state of suspense for multiple days that they were still alive. But a lot of people deduced that the news probably would have had that information about the Drake system.
I mean, I felt like an idiot when I found out the truth because, I took my perspective, particularly from James Cameron, the director of the original Titanic movie, and he was saying from his dives, because he's done a lot of dives. He's gone to the Marianas Trench, stuff like that.
Mm-hmm.
And of course, he went to the Titanic in a much safer vessel. And he was saying how if you lose all communications, because there's multiple sources of communication. So like if they're losing like electrical contact to like the motors, if they're losing communication to the surface, and I guess there was a third too. I don't remember exactly what it was. But if you lose one, then it's like okay, they're definitely still there. If you lose all three, they're gone, and you know it. So after like hearing his take on that, I was just like, what? Why didn't I think of that? Like that should have been the obvious truth to me. But
Yeah, like so when I worked on airplanes, one of the roles that I played was every once in a while I would have to go to the black box and check the underwater acoustic beacon, and I had to make sure that it was the batteries were good on it, and make sure it was a proper operation. And so I had like a test set, but you could literally like short this thing out on your cheek, and you could literally feel it against your cheek like working. And like so, I was surprised that they didn't have that on their vessel because that can be sensed from a depth of 14,000 feet. So if they were going 12,500 feet, it would have still worked. And like in the event of the unlikely scenario where they just lost communication and they were stuck somewhere, um, they still would have been able to been detected wherever they were if they had one of those acoustic beacons. And I can't imagine that they would have been like a lot of money to put one of those on there.
yeah, but also, can it handle those depths? Because
Like I said, like it is designed to operate at a depth of 14,000 feet.
okay, but
And
just like within a vessel or just on its own.
so the way it's designed is it actually sits outside of the black box. It's mounted directly to it.
Oh, okay.
And so it's it they the one that I worked on in particular sat up in the tail of the plane, and it's designed to the whole system is designed to just turn on if it hits like a certain impact value. And but that particular little device is shorted out by water.
Oh,
That's what makes it work. So like
hmm,
once it detects water, it starts clicking at like a certain rate,
yep.
and then that's what they can use to be like, oh, I can hear that click, and then they can go find it that way.
Okay.
And so that's what I was getting at. I was like very surprised that you wouldn't exhaust every angle you could of like for chance of survival related things.
I mean, I'm sure all the search parties, and at least like the military search parties involved, they knew they were just going straight to the last point of communication, going straight down just to confirm. Yeah, it's gone.
And
Um,
I actually took the amount of time. I took the amount of time that they went before they lost communication, and then I took the average rate of descent of that particular vessel to figure out where they actually were in relation to depth.
mhm.
And so they were down there. They were,
Yeah. Well, I heard. I don't know if whatever the information you got was, but I heard they were around like the 3,000 foot mark or whatever.
a little bit more, but yeah, like right around
Like they
there.
were at like 3,500 trying to go to 38 or something.
Yeah, something like that. But like, I mean, because they were going at a pretty constant rate. But like, yeah, I think that's crazy that they made it that far. And the crazier thing to me is that this thing survived so many times going to that same journey.
Well, that's why I'm thinking, that carbon fiber over time, that fatigue stress.
Yeah,
It just seems like, oh, it's fine. And then sure, it'll handle pressure to a point. And they found the point.
and that's what I mean. So I was talking to my buddies about this, about like point of failure, and how like I'm surprised that they never really took that thing to point of failure before putting it into
Hmm.
application. Because when you want to know that, like when you want to know over time, and it must, I think the R&D must have been just way too expensive for a guy who was doing
Yeah.
basically an independent,
I
you
mean, the
know.
R&D was going to be millions, but clearly people were willing to pay like 100,000 to quarter million per trip per person. So like you're talking if you spend 10 million, you take what 20, 30 people down, you can probably recoup your costs and still keep going. Which if you could only take 30 people down in a year, in 2 years you're good. You know,
Yeah.
that's a good business. That's if you do all your homework. I could be wrong. I don't know the exact numbers of everything they spent, but
So
it sounds in the realm of possibility for what people were willing to pay to do that trip.
yeah, yeah. So there's this submersible owned by Gabe Newell, the guy who owns Valve.
Okay.
And I guess the guy who originally invested in this submarine paid $37 million, and the name of that vessel is called Limiting Factor.
Hmm.
And I thought it. So I guess that one has gone to all the different. I guess there's like five really deep spots of ocean, and this one has gone to every single one.
Huh.
But I guess like this thing's only like the cabin inside that thing's only like 59 inches wide, and it is that spherical shape that I had told you about earlier,
Mm-hmm.
and it's made out of it's certified, it's inspected, and I guess you can only fit like two people in it, but like they did their homework, they did their stuff, but that was the cost. It was 37 mil.
Yeah. I mean, that is a lot. And I don't know if you have to go to that extent for going to see the Titanic, but they could have easily contacted someone like Gabe and figured out to what level they should go or how much they should spend to, make something safe that will work for years.
Right. Well,
It's a shame.
do you have anything else to say about this matter?
I think I'm pretty wrapped up on it. I've heard a lot. I've learned some new things from you today on it. I didn't know about all this stuff, and I didn't think you would get this technical into the engineering behind it. I was really impressed.
All right. Well, thanks for coming, Cam, and I hope you enjoyed this like I did,
Yeah, this was
and
great.
hopefully we can do it again.
Yeah, thank you.
Thanks for listening, everyone.